First of all, I would like to thank ICTS for giving me the opportunity. So here we are exploring the interaction of jets in the cluster environment, and I'm presenting the preliminary results of our study. First, as all we know, radio galaxies emit jets on both sides, and these galaxies are classified by classically. These galaxies are classified by Fanroff and Riley on the basis of their radio morphology and the radioluminosity. So the formula is distance between two hotspot divided by so distance between two hotspot and divided by total extent of the source. If it is less than zero point 0.5, it is FR1, Fanroff-Riley 1. And if it is greater than zero point 0.5, it is Fanroff-Riley 2 source. So FR1 sources generally have power luminosity limit, which is less than this. And FR2 sources are powerful sources, which has radio power greater than this cutoff. Now, now there comes a third kind of source, which we call hybrid morphology radio sources. This sources has both FR1 and FR2 types of jets in it. One side is FR2, as we see in here, and the other side is FR1. This is the one of example. We call it as HIMORS. So detecting this kind of source raises the question about the standard model of classification of FR1 and FR2 sources, because it is coming out of same agent with same power. Now here I will first talk why we choose HIMORS, then our sample, then we will go through the results, and finally we go to the conclusions. This is the image of GMRT C3 antenna, and here I am. Now, why HIMORS? First, as we know, radio morphology primarily depends on two factors, agent power and surrounding medium. By choosing HIMORS, we can neglect this parameter as both jets are coming out of same agent. So we can divide surrounding medium into further three categories. First is immediate surrounding, which is the host galaxy, which can also be neglected as both jets experience same host. So we can study the interaction of jets with the intracluster medium and the environment created by the motion of other galaxies in the cluster. Now coming to the sample, we have well-defined criteria for the sample. The first point is it should have clear HIMORS morphology, like as in this image. Next, it should have known spectroscopic redshift. It should be a member of a cluster. To achieve a desired sensitivity, it should be observable for at least 5 hours from the GMRT. And the last, it should be, its size should be at least 3 arc minutes. Now we have selected our sample from Meerkat Galaxy Cluster Legacy Survey. We have a total of 8 HIMORS, from which I have plotted 5 HIMORS in this diagram. This is the position of HIMORS with respect to their respective cluster centers. Now, data is available in 3 surveys: TGSS, which is at 150 megahertz, MGCLS, which is in L band, and VLAS, which is in 3 gigahertz frequency. So we observe the sources at GMRT band 3 and GMRT band 4, which is at 400 megahertz and 650 megahertz. And the optical data is taken from DC Legacy Survey. Now coming to the result, this is our first source. This is GMRT band 3, this is band 4, Meerkat L band, and this is optical image with Meerkat contours overlaid on it. So in this image, we can see that optical host is sitting at this position. So jet coming out of this direction is edge brightened. So we can call it as FR2 jet, and jet coming out of in this direction, this is looking like a diffusing. So we call it as FR2 jet. So becoming an HIMORS morphology. Now, so as we can see in this image, both the tails of coming out of this jet are in the same direction. And if we see the source location with respect to their cluster center, it is sitting at this position. and both the tails of the source are away from the cluster center, which therefore we can predict that it is moving in the cluster potential and towards the cluster center. To confirm that, I have divided this source into 8 different regions and plotted the spectral index with respect to the different regions. This region 4 is at the core of this source. So as we can see, the spectral index getting steeper and steeper as we go away from the core, suggesting each radioplasma. In this region here, we can see a clear spike or gradual increase in the spectral index, which shows the clear transition between this active active plasma and the backflow of the plasma. Next, this is a source 2. So in this host is sitting here. We can see the jet coming out of eastern direction is clearly an FR2 jet, and the other direction, this is an FR1 jet. So if we focus in this region, and if I plot, if I have different bins along this region and plotted integrated flux, I get a peak which suggests there is a which suggests the presence of rim of jet. So this jet coming out of this direction is having a bent in this direction. So the culprit for this is here, which is another nearby galaxy. So the jet coming out of this direction is interacting with this galaxy and having a bend. I also like to include this plot. This is integrated flux throughout the source, and in this region we can see that there is a homogeneous flux. Next, this is source 3. We can see here, this is initially an FR2 jet, and this is a little dimmer, likely FR1 jet, but we have assumptions that this different flux density is might be due to a relativistic beamings, that this jet is coming towards us and this jet is the counter jet going away from the us. Otherwise, this source is also a BCG brightest cluster galaxy sitting at the center of a cluster. So there might be a possibility that it is experiencing a dense cluster environment, which causing this morphology. And also there is another story. So this source, this is also, and so this galaxy is also have a similar redshift with the source. So there might be there is a possibility that jet coming out of this direction is interacting with this galaxy, and the plasma is like diffusing in this direction, which making this FR2 jet look like a FR1 morphology. So finally, we can conclude that there are 3 or 4 possibilities that a source can be an HIMORPH. First is if it is moving in the cluster environment. Second is if one of its jet is interacting with the nearby galaxy. And the third is either it is relativistic beaming effects or its interaction with the intracluster medium. Since these are preliminary results, we are also planning to do spectral mapping and also to study the interaction of jets with the galaxy, like change in star formation rate of that galaxy, or uh, yeah. Thank you.
Questions? Question. That quick change in spectral index you showed for the region 3 and 4 for the first source, can it also happen because this that upper jet is kind of oriented along the line of sight?
This jet you are saying?
Yeah.
didn't explore this possibility. Maybe I will look into that.
Anything else? Yeah, there.
When you were saying the distance between two lobes, how do you define the lobes and how do you exactly measure the distance? I mean,
The maximum brightest pixel in that lobe from the core.
and regarding this steep change in the spectral index, so I mean, why these two things are coming to be that different? I mean, as Prashant was mentioning, there must be any significant physical interpretation. Can you say something like that?
So, as I said, this region has an active plasma, like jet hitting continuously in this region. So, and in this region, it is the plasma is backflowing. Maybe that might be a possible reason, but confirmation will come from the spectral maps.
Okay.
Thank you. Let's thank the speaker and we move to the